Okay, so in this question, we're told that there's a company that carries out an investigation into the strengths of rods from two different suppliers, Ardo and Bards. So we can use A and B. Independent random samples of rods were taken from each supplier, and the force that was needed to break each rod was recorded. The company wrote the results on a piece of paper, but unfortunately they spilled ink onto it, and some of the results cannot be seen. So, this image that we're shown here with the big black blotch, lots of students in the exam or in a practice assessment have thought that something is actually wrong with their exam paper. But reading the context of the question lets you know this is done on purpose. It's part of the question they've designed. So we have some of the data here, and we've been asked to use the data from Ardo to calculate an unbiased estimate, S squared, of the variance. Okay, well, let's see if we have enough visible data to do that, starting with the formula. So the formula for the unbiased estimate of the variance, or S squared, is n over n minus 1. And then we're going to have the sum of x squared over n minus the sum of x over n squared, the mean squared. Okay, let's substitute what we know. Firstly, the sample size for Ardo is 7, and actually I have all 7 values for Ardo. So there isn't much missing of the original data for Ardo. So I'm just going to put this into the calculator so I can see all the summary statistics. And there I have the sum of x squared and the sum of x, and these just need to be substituted in to generate my S squared value. So 7 over 6, 1257.78 over 7, and then 93.8 over 7. Okay, just order that into the calculator and we get 0.1433. So that's going to be S squared, our unbiased estimate of the variance. Part 2 of A says, hence, we should then find an unbiased estimate, S squared, of the variance of the sample of 9 values from Bards. Okay, well, how are we going to do this? I notice that we've been given the pooled estimate of variance, which means they must have combined S squared A and S squared B. So I'm just going to set up an equation for the pooled variance and rearrange to solve for S squared B. So here's that familiar formula. Substituting in the values that we know, so we know the pooled variance, we know S squared for A, we know the sample size for A. We don't know S squared for B, but we know sample size for B. So that means that we know the whole of this denominator to be 14. Alright, so just some smart rearranging from here, and we can get S squared. So let's do this all in one step. Multiply by the 14, subtract 0.1433 times 6, and then divide by 8. And into the calculator, that gets us 0.3493. Okay, on to part B. In part B, we're asked to test at a 10% level of significance whether or not there's a difference in variability of strength between the rods for Ardo and the rods for Bards. So here we're going to do a hypothesis test for the difference of the variances. This is going to be an F test. Okay, let's set up the hypotheses. The null hypothesis, as always, is that the two variances are going to be the same. The alternate hypothesis, variance of A does not equal variance of B. So 10% level of significance. This is a two-tailed test, so this should be alpha over 2, so 0.05. Critical values, we can find those by looking up in the tables. And we're going to look up with the parameters 6 and 8. And we're going to use the 0.05 section of the tables. So from there, we get 3.58. At the other end, it's going to be 1 over 8 and 6. So that's another critical value into the calculator, and we get 0.241. What does this look like on the diagram? Well, here are the two critical regions. We'll just check our test statistic and see whether or not it ends up in the critical region. The test statistic is going to be S squared A over S squared B. And into the calculator, we get 0.4103. Okay, so where's that? That is outside of the critical region. It's here. It's below 1. 1 will be optimal, but it's not low enough. It's not far away enough from 1. So we do not have a significant result, but we'll give our 2 conclusions as usual. The mathematical conclusion, there is not enough evidence to reject H0. And in context, there is not enough evidence that the variance in strength for the rods made by Ardo is different from the variance of the strengths of the rods made by Bards. Part C of the question asks us to test whether the mean strength of rods from Bards is more than 0.9 kilonewtons greater than the mean strength of rods from Ardo. So here we're going to do a difference of 2 means hypothesis test. So let's start with the hypotheses. The null hypothesis is that mu b minus mu a is going to equal 0.9, whereas the alternate hypothesis is that that difference is greater than 0.9. Okay, it's a one-tailed test, 5% level of significance, and let's now find our critical value. Now, our sample size is small and we do not know the variance. This means we're going to be using the t-distribution. So let's find the critical value for the t-distribution. Find the t critical value with a parameter of 14 and a significance level of 5%, 1.761. The 14 has come from subtracting 1 from each of the sample sizes and then adding them together. Okay, so that is our critical value. What's that going to look like on a diagram? Here's the 0, 1.761. If we standardize and our test statistic leads to a t-score that's in the critical region, we will reject H0. Let's go ahead and standardize. So the t-score, well, that's going to be x bar b minus x bar a, subtract the difference between the 2 means in the distribution, and we're going to divide that all by the pooled standard deviation. Okay, so 1.4 is the difference between those 2 in the sample, 0.9 comes from the population, and we've got 0.261 multiplied by 1/7 plus 1/9. This gives us 1.94. 1.94 is in the shaded region, it's in the critical region. This is a significant result. 1.94 is greater than 1.761. We can reject H0. So the 2 conclusions as usual. Firstly, the mathematical conclusion that there is enough evidence to reject H0, and secondly, the contextual conclusion that there is evidence that the mean strength of the rods from Bards is more than the stated 0.9 kilonewtons greater than the mean strength of the rods from Ardo. So if you want to buy some rods, Bards is the place to go.